But here, we're going to look at what are the key characteristics of an exponential function. So go ahead, slide your notebook out. We're just going to write down a few things. There's not going to be a crazy amount of notes. All right, so let's look at this. Exponential functions are learning targets. Students will be able to differentiate between linear and exponential graphs. So just like we did in that warm-up, we are going to lean heavy today on what is the difference between a linear graph, which we talked about in chapter 5, and an exponential graph, which we're going to look at today. Students will be able to compare exponential graphs. So we're going to have different types of exponential graphs, and we're going to say, all right, what's different about these? Why is it different when we look at the equations? Students will be able to use exponential graphs to solve real-world problems. So you'll see as you go through the rest of your high school career with different science classes, especially, they'll talk about exponential growth and exponential decay. And that would be solving real-world problems. So I'll leave it at that for right now. So we're going to review for a second, look at a few things, and then keep going through some other things. That's true. I think we've done a lot of review. So let's skip to exponential functions. So here's the formal definition. A function of the form y equals a times b, so to the x. So this is our exponential form. I would not write down that whole paragraph right there, I don't think. But I would write down what I'm about to write down. So far, we know y equals mx plus b. And what does the m value represent? Slope. And what is the b? Y-intercept. So that is the form of that is the equation for the linear functions. Remember, linear function just means a line. That is what we've looked at. Now, when we look at these exponential functions that are more sloped, here's the equation that we use in building those. Y equals a times b to the x power. Now, in our exponential function, the a value is our y-intercept, and the b value is, we don't call it slope with an exponential function because slope implies that it's staying the same. We call it, remember I mentioned the common factor? I think that's how she mentions it in that video, if I remember correctly. Yeah, I think she says common factor. So those are the key characteristics of our exponential function. The same types of ideas, just we use, I'm not sure why they use a different letter for your y-intercept. I do get using a different, and then they use b for what we are used to being our y-intercept, but it's our common factor. So I'm not sure why they switch things up when it comes to that exponential function, but they do, so we need to be careful there. So if we look at these two graphs, want you to take like 30 seconds to look at these and decide if they, well, if number 1 and number 2, if it is a linear or an exponential function. Jot it down on your paper for number 1 and number 2, which one it is, and think of a reason why. All right, if we look at number 1, how many people think that that is a linear table? Number 1, linear table. A couple, 3, 4. All right. How many people think it's an exponential function? The rest of you, yeah, I would agree. It is an exponential function. Now, if we look at our x values, they're consistently going up by 1. So we're clear there. That's all good. No big deal. If we look at our y values, we get from 8 to 4. We are subtracting 4. When we go from 4 to 2, we are subtracting 2. So once we see that right away, we know that we are not dealing with a linear function, because a linear function would have something consistent. It would be minus 4, minus 4, minus 4 every time. But since we go minus 4, then to minus 2, we need to rethink what we're doing. So we need to think about, how do we get from 8 to 4 without adding or subtracting? Yeah, Trevon? Nice. We divide by 2. So you'll see again, divide by 2, or they'll say multiply by 1/2. Same exact thing. How do we get from 4 to 2? Well, our pattern stays. We divide by 2, and we divide by 2. So we can see that we have an exponential function. Now, to take it one step further, what if we needed to write the equation of this table? Can anyone take a stab at that? You know that A has to be the y-intercept, B has to be a common difference. So what would our equation be? Corbin, is that a hand or a stretch? All right, try it. Come on, be bold.
Would it be y 8 divided by 2?
So I get where you're coming from with that, and that wouldn't work, but I get where you're coming from with that. Instead of, we don't want to, even though up here we can think about this as we're dividing by 2 every time, the reason I keep bringing up that we want to think about it as multiplying by 1/2 instead is because in our equation we can't write it as a division sign. So we have to write it as multiplied by 1/2 in our equation. And that would be to the x. So, totally right idea, Corbin. We're just going to write it in a little bit of a different form. Okay?
Corbin.
Yeah. There you go, Corbin. You got to pop the headphones up for me, too. Or not. I know you might not be listening to anything, but just in case. All right, number 2. Are we looking at a linear or exponential function? What do you think for linear? Now everyone's scared to say that it's linear because they're doing exponential. All right, exponential. Let's see. Our x's go plus 4 for 4, so our x's are all good. The y's are what will tell us if it's exponential or not. Or exponential or linear, so we go minus 1, minus 1, minus 1. We have a linear function. Good job. And I won't go over how to write an equation for that because we did that all in chapter 5. And all of you could do that in about 10 seconds right now. All right, last one I want to look at. Here's an example of one of the types of problems you will see. And this is where we talked about in the beginning comparing different exponential functions. Here's what we'll do a little bit of comparing as well. So it says graph y equals 2x plus 3. Describe the domain and range. And then compare it to the graph of y equals 2x. So I put that table on there. And when we are graphing these exponential functions, it's really difficult for me just to look at the function and look at the equation and just graph it. So what I do is find a couple of the points. So you don't have to find all of these. I'm just going to have you find those 3 points on the graph y equals 2x plus 3. And then sketch a graph of what that would look like. So go ahead, take about 2 minutes. Plug -2 in for x. We're using this equation here. -2, 0, and 3. Plot those points on a graph. Just quick sketch it on your paper and get an idea of what that function looks like. Yeah, mind your what? What? Yeah. Oh, sorry. Michael, look what you did. What's happening? Michael. All right, find those. Sketch your graph. Sketch your graph. The graph that I am sketching is of y equals 2x, so do not copy it because that would not be correct. Use your calculator. Don't try to do 2 to the -2 plus 3 all in your head. Well, you can if you want to, because you know how. You do know how, but punch in your calculator. No, that's not what I said. Punch it in. Yeah. Big difference. No, you missed the keyword there. Punch it in. You should, if I knew how to write intention, I would write it so fast right now, but it would be fun. Like 6 of them. Yeah. No, Alright, I think we're ready. So, what is the value of -2? In our table, -2. -1? Do we agree?
Yeah.
-1?
Really? I'm probably wrong because I'm pale. Or is it the...
That's not what I got.
It's the other way.
For 2 to the x plus 3.
Oh wait. I wrote it wrong.
Is it -1? Is that what you got?
I wrote it.
I just did this morning. Did I do it wrong?
4 plus 3.
What? It would be -4 plus 3. Nope.
I wrote it.
Guys. Guys.
Yeah.
Everybody. 2 to the negative 2.
Never mind. Stop it.
That's what I did.
Is this a negative number? Will this end up being a negative number? No, it is not a negative number. So what did we just learn? I'm going to lose my mind. We can rewrite this as 1 over 2 squared. 1/4. 1/4 plus 3. 3 and 1/4.
Oh my God.
Holy smokes. Do we? Well, I shouldn't ask that. Never mind.
Remember I said
Maybe is math that important? Like.
All right. Yes. 2 to the 0. What is anything to the 0? Nothing. It's 1. 1 plus 3. 4. Now 2 to the 3rd power. 2, 4, 8. I feel like someone's going to say that. 2, 4, 8. So 8 plus 3 would give us 11. So if we are putting this on a graph, negative 2 to the 3/4, or 3 and 1/4, would be about there. 0, 4 would be about here. And 3, 11 would be like way up there. So this graph would look something like that.
Yeah, that's alright.
Now, if we describe the domain and range of the blue graph, domain and range. Listen up, we're almost done. We're almost done. I know I've been talking for almost 18 minutes. What would the domain, what are all the possible x values of this graph? Lucian, what do you think? All the possible x values of this graph. Could it be negative 10? Could negative 10 be an x value of a blue graph? No? Negative 10 over here, our graph will still be going. All possible x values. It could be any x could go into this. Now the range. This is where it gets a little bit tricky.
It's been tricky.
It's been tricky. The range. And I want to ask for this one. So, with our range, listen up. This well, let's look at this. This 2 to the x. This 2 to the x. Could this ever be negative?
Yeah. No.
It could?
No, it couldn't.
Any number we put in for x, would it ever be negative?
No.
No, it would never be negative, ever. Now, this plus 3 at the end moves our graph up. So the lowest that our graph can be is just 3. Right? Because this will never be negative. This 2 to the x will never be negative. And we have this plus 3 at the end. So the lowest our graph could be would be 3. So for our range, y greater than 3. Now, what if it had just nothing on the end? Then it could go down to almost 0. It never would get to 0, but almost 0. What if it had negative 6 on the end? It could go below. It could get almost to negative 6. It would keep getting closer and closer to negative 6, but it wouldn't actually touch negative 6. So when we look at our range, we need to look at what is tagged on to the end here. Okay? So this is the part where usually I'd have you try a problem, and then you'd get the worksheet.
Oh, a worksheet?
But I think I'll just give you the worksheet. So depending on how we do, how much time do we have left in class? 19 minutes? So depending on how we do, the next 15 minutes will depend if we'll make a difference on if this worksheet is homework or we finish it as a warm-up tomorrow. So if we stay on task and we just don't get it done because we're still learning this stuff, then it would be a warm-up tomorrow. If we're thinking around, then, well, then homework happens. So,
My favorite.
so you guys have been doing awesome. So stay on task. I do think you could pretty much finish this either way if we stay on task. So I'm leaning towards just leaving it as homework if we don't finish, because I think you guys can get it done.
Oh no,
It's one page. It's one page. It's just spaced out. I do. Yep.
What? You do like evens or odds?
No. This is one. There's literally one. These will take 30 seconds each. Great. Well, ask me questions when you get there. I'll show you. Yeah, definitely. There's a pen. Oh, it fell under the chair. There you go. On the first one, be careful because the first graph is y to the x squared. Remember, our exponential function needs x in the exponent. So y equals x squared.
The second one.
It says which equals exponential of y. We know that one's done. Did I say it out loud? Yeah. Have you guys learned quadratic graphs in Algebra 1A? Well, I meant to ask shoot if you guys did that or not. But that would be something like this.
No. Oh wait.
You've never seen this before?
No.
No.
Well, I thought you had, so that's why.
That's right. You got it really loud.
Otherwise,
That's you. I mean, that's true, but.
I don't even have. How about a kitchen? Exponential straight to the curve.
Riley, have you gotten the first one done yet? Is it Lucian's fault that you haven't gotten the first one done yet?
What?
What?
That's okay.
All I hear is don't shoot me with the pen. Stop hitting me with your ruler.
I don't even have
Let's go. Get working. Oh, stop recording.